Welcome to my discussion video. Today I'm going to explain the approach I took to improve the performance of classifier and how assessed and improve as it fits. So I want to talk about the data processing and feature engineering first. Basically, I did nothing because once I checked the starter notebook and used PyCaret, the results is kind of ridiculous and you know it's not great, and the F1 score is extremely low. So I start my own notebook. So firstly, I started with reading the training and the test dataset from CSV file. I process the categorical variables using label encoder so that the encoding is consistent across both datasets. Then I extracted the feature and the labels from the training dataset to ensure that the model learns effectively. I applied a mini-max scaler to normalize the feature so it can boost the training speed. And also, I found the data is extremely imbalanced. I handle that with Smalt. One of the major challenges I face, is the class is extremely imbalanced. To address this, I use Smalt to oversample the minority class. I set the sampling strategy such that the minority class constitute 20% of the data after oversampling. This sample is vital to prevent the classifier from being biased towards the major class. To improve the performance of the classifier, I built a neural network with following components. The dense layer, the neural network has three dense layers with 180, 128, and 64, and 32 units respectively. Activation function, I use the switch activated function. I also tried Reru, which is not as good as switch, which often switch often performs better than traditional activations like Reru. Also, I tried regularization to reduce overfit, and I used the batch size normalization and dropout to help me to stabilize and accelerate training. I compiled the model with Adam W optimizer, which adds weight decay for additional regularization, and used the binary cross entry, entry as the loss function with accuracy as metrics. Also, I used the cross validation for robust evaluation to access the model's fit and the stability. I used five folds of cross validation. For each fold, I split the data into training and validation set, applied Smalt to the training portion of that fold, and trained the model using array stopping and the learning rate reducer to avoid overfitting, to adjust the learning rate dynamically based on validation rules. And I calculated the F1 score as metrics. By averaging the F1 score across all folds, I obtained a robust estimate of the model performance. This cross-validation step was essential in determining that the models generalizing well across different subsets of the data. For the final model training and submission, after accessing the classifier using cross-validation, I trained a final model use all the data. Again, balanced using Smart. In this final training phase, I didn't split the data into training and the validation sets so that the model could learn from the maximum amount of data available. I monitored the loops during the training with early stopping to prevent overfit and reduce the learning rate as needed. I also spot the training rules and accuracy curve, which allowed me to visualize, inspect, the model's convergence. Finally, I use the train the final model to predict the test set and generated a submission file. And the result is good. I currently at the third place of the entire leaderboard. And thank you for listening.